This video will compare the principal component analysis, abbreviated as PCA, with the factor analysis, abbreviated FA, in the first section. In the second section, the video will also compare the exploratory factor analysis, abbreviated as EFA, with the confirmatory factor analysis, abbreviated as CFA. In this presentation, two methods, statistical methods, will be compared: the factor analysis and the principal component analysis. Factor analysis and principal component analysis are related. They are similar. However, both are not identical. Both are statistical multivariate analysis methods aim to reduce the dimensionality of the data. That is the common things between these two methods, abbreviated as PCA and FA. PCA is merely mathematical technique or method that aims to reduce the data dimensionality, i.e. reducing the number of items. It is frequently used in survey and questionnaire analysis to reduce the large number of items or questions through the method of principal component analysis. Factor analysis, on the other hand, is designed to identify unobservable factors from observed variable. It aims to identify latent factors that explain the correlations between observed variables. So there is a subtle difference between PCA and FA. PCA is a data reduction techniques, reduce the number of items. FA is designed to look for latent factors. So both have different approaches and assumptions. Choosing which one to use, whether PCA or FA, depend on the underlying assumptions of the data and the objective from the research study. PCA is merely dimensionality reduction technique. It aims to group set of variables or items or questions from a survey or questionnaire into a new set of uncorrelated variables called principal components. That is the main target of or objective of performing PCA, to generate principal component, group these set of or collection of variables into components. These components retain maximum variance in the data. However, the FA is a method to identify latent factors that underlie observed variables in data. Its aim to explain correlations between observed variable via number of underlying and unobserved factors. So there is a major difference between both these techniques. The first one is reduction technique. The second one, search for latent factor. This latent factor will explain correlation between variables when they are arranged into factors or constructs. In terms of assumptions, PCA assumes that principal component generated are linear combination of the original variables, and these components retain or explain the maximum variances in the data. The FA assumes that the observed variables are affected by underlying latent factors. those observed variables have a unique variance that is not explained by the factors. So FA will look for common factors and unique factors. In terms of the interpretation, the PCA, the principal component or components generated or obtained from the analysis, do not have an interpretation in terms of the original variables. They are mathematical constructs. So these components are mathematical constructs representing variance in the data. For the FA, the factors extracted from the factor analysis are intended to have a meaningful interpretation in terms of the observed variable. Each factor is associated with a subset of observed variable that have high loading on that factor, indicating a strong relationship. So in FA, a construct is generated or factors are produced. Those produced factors have a meaning as they have in them items or variables that measure that construct or factor. In terms of variance explanation, the PCA aims to explain maximum variance in a data by producing a principal component. The first principal component explains the most variance. The second one explains the second most, and so on. In FA, the focus of the factor analysis is not on explaining the variance, but rather than that is to identify the underlying factors that can explain the correlation between the variables within that factor. For rotations, PCA, the principal components produced are orthogonal to each other, meaning they are not correlated. In FA, factor loading are not necessarily orthogonal, and different methods of rotation such as Varimax, Promax can be applied to make the factors more interpretable. In this video, I will describe the differences between the exploratory factor analysis, abbreviated as EFA, and the confirmatory factor analysis, abbreviated as CFA. What are the difference between two methods and when to use each method at any stage of survey or questionnaire or scale development. So, what is the difference between CFA and EFA? CFA and EFA both are similar statistical techniques. Both are multivariate statistical method. Multivariate means there are several variables or items or questions. So it is a multivariate statistical method that is used to examine how well observed variables represent a number of constructs or factors. So you do have a collection or a group of items or questions or variables, or the same meaning when developing a questionnaire or a survey, and those variables need to be sorted into factors, or in another word, constructs. In EFA, the data is explored initially and examined, and the number of factors or constructs representing data are determined. So in the EFA, the number of factors that represent the set of variables or items are explored, examined, assessed, identified. In EFA, all the observed or measured items or variables are associated or related to specific latent factors. So each factors will be represented by certain number of items or questions or variables. So in EFA, the factor and the number of variables that represent that factor or load to that factors are determined. Thus, a model can be constructed representing the structure of the factors with the items associated with the factor. On the other hand, the CFA is a statistical method, multivariate statistical method, that is used post performing the EFA, and it is used to confirm or disconfirm the factor structure or the model structure or the hypothesized model that have in it the number of the factors and the number of items that is linked or associated to a specific factor. So statistician can specify the number of factors representing the data and which variable is associated with which latent factor. So the statistician will build up a model that have in it certain number of factors and how many items that represent that factor. So in EFA, the method is more suitable, proper than CFA in the initial stages of questionnaire or survey or scale development. So when you at an early stage of developing the questionnaire, then the EFA is the one to go for. As if you commit any mistake during the determination of the number of factors and items linked to the specific factors, in the EFA, incorrect defining of the number of factors at early stage of the scale development cannot be detected by CFA. However, in EFA, it is possible to redo the analysis, omit certain items or variables, rebuild the structure of the factors with the items loading to the factor. So there is a possibility for modification and changing the structure of the model or the factors. However, in CFA, this cannot be done, as the factor numbers and the items numbers have to be determined in advance before performing the CFA. So CFA does not show how well items load into undefined factors. So there have to be a model for the structure of each individual factor, and the CFA cannot show how well the items load into undefined factors. CFA is used at a later stage or stages of scale development or questionnaire development. So it's not an early stage. EFA is an early stage. The CFA is a late stage. The CFA is used for confirmation of a specific factor structure based on EFA. So EFA will determine the number of factors and the number of items. The EFA will propose a model for the data. Then the CFA will confirm or disconfirm the structure of the model and the number of the factors with the items loading into it. Though CFA is a confirmatory factor analysis method, it is not absolute confirmatory analysis, as there is a window for modification via using the modification indices, which is used in CFA as exploratory. What does that mean? That means you could have a possibility to modify the structure of the model by omitting specific items that does not well fit or represent the factor structure. So modification indices can improve how well the model fit the data. Though there are certain differences between the two methods, again, EFA is an early stage, CFA is a later stage. EFA can be performed without any knowledge or hypothesis or information about the structure, the number of the factors, and the number of items linked to specific factors. In CFA, things have to be clear and well defined in advance. A model has to be built, proposed, a hypothesized structure for the data with the number of factors and the number of items have to be clear when performing the CFA. Though the CFA has a flexibility in a way that it is possible to omit certain items that does not or do not represent well or load well into certain or specific factors. So EFA is used when researchers don't have a clear understanding or hypothesis about the structure of the factor. There is no model for the data. EFA is used to explore and uncover those factors that might exist within these measurable variables. So you have a set of data, then the EFA will sort the items into factors, and those factors will have specific items load into those factors. And that is why it is called exploratory factor analysis. For model specification, EFA does not have a pre-specified factor structure or a model or a number of factors. It's just only start with a collection of items to sort these items into factors, those factors represented by specific or certain items. So the EFA explores various factor structure to identify most suitable model that explain the measurable items or data. So it is an exploratory factor analysis to try to define, determine, identify how many factors represent the data and how many items loads. So EFA is data driven. CFA is hypothesis driven. So this is the major difference between both. So EFA is data driven. It allows for the identification of patterns and relationships within data without any limitation, without any restrictions, without any predefined structure for the factors or the number of the factors and the items that load to the factors. So EFA presumes that any observed variable may be related with any factors. So the EFA assumes at the beginning that any items can be associated with any factors, and then the EFA will determine and define which items or item is associated with a factor. When developing a scale, statisticians should use EFA first before using the CFA. So EFA first, then move to CFA. And to do CFA, you need a new set of data to confirm your initial proposed hypothesis or a model for the data that is performed using EFA. So EFA is important for defining the underlying factors for a set of measured variables. EFA requires the researcher to make important decisions on how to conduct the analysis, as there is no one set method. So the researcher will take the data, load them into the software, perform EFA, and then EFA will produce an initial proposition for the model or the structure of the factors with the items in it. There is a window for modification until reaching the stage that the items load highly into factors. The CFA, on the other hand, is hypothesis driven. There have to be a predefined model or a hypothesis about the structure of the factors and the items or variables that load into the factors. So the CFA allows the researcher to test the hypothesis that is already generated from performing EFA, that the relationship between the observed or measured items and their underlying latent factors, which could be described as a constructs. And the objective of the CFA is to test this hypothesis that there is a relationship between items and latent factors. So the factor structure or the model is already determined via the EFA. So the message here is that EFA has to be done first, then the CFA can be performed later on a new set of data to confirm or disconfirm the initial proposed model for the structure of the factors that represent the data. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic or Statistics, GraphPad, Prism, GPower, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, RStatistics, GraphPad, Prism, Mann, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.